Alright, today we are going to work on the pumpkin tilt and hurl. This is an actual full functioning, no issue tilt and hurl. Because so many people are having problems with this unit, from throwing the pumpkins off to not spinning, losing drive, overheating motors, etc., I'm going to take apart a fully functional one to try and find the weak points and get cross-reference information on how to replace the motor, drive belt, gears, etc. Just to show you, fully functional, full rotations, no throwing the pumpkins off. See it in the dark in case you haven't seen one. I'm sure you have. It's not a new piece. It's a year or so old. There you go. Also, I need to see what it looks like so I can remember how to put it back together. Turn on all the lights. So we are going to break it. At least I hope not. So, as you can see, she's been rotating several rotations, hasn't thrown a pumpkin, because I know that's a very common issue with the little pumpkin figurines being thrown off the platforms and then potentially getting broken since they're fragile. I don't know if mine's just different because the magnets may be closer to the surface and they're sticking better, as far as there's not a big air gap, which means the magnetism is weaker. Not sure, but this one actually functions like it was designed. If you are having a problem with the pumpkins being thrown off, putting a very clean off the white lithium that they put on here, and put a very small dab of glue between the two magnets and stick it on. Hot glue, not super glue or anything, because that allows you to twist or snap the character back off and store this if you'd like. Use super glue or an acetate glue, you risk, one, never getting it off without breaking these rotating pads, or potentially breaking the bottom and pulling this insert out with the two magnets in it. So everything on this is magnetic, which is kind of nice. Well, all the accessory parts. You can see, and there's the white backlighting. And that's what it looks like and sounds like with nothing on it. I'm going to assume this up and down mechanism is the same they use on the carousels. I won't know until I open it. I have not personally opened one of these yet. There are 3 screws in the top. So I'm going to grab a small screwdriver and we're going to start there. One. Main reason I'm doing this is there's a whole bunch of different threads I've come across where it seems like most everybody has problems with this piece. I'm one of the lucky few, I guess, that have not had any issues, and now I might, since I'm taking it apart. So the little white strip light is double back tape onto the edge. You can peel it off and tack it back on with glue, or because they're nice enough to give you some slack, set it off to the side. I am going to disconnect the power, just in case I bump it. I don't want it to catch and potentially tear something or damage something. Here's your little speaker, a little 8 ohm 2 watt speaker. It's different than the more common Lemax speakers. I've noticed that in the past couple of years, certain houses are coming with different speakers. They used to all have the same style, same type, same size. Now they're actually changing them up, which is very surprising. Because when you change something, it means it usually costs money. So pull out the screws. Set those off to the side. Over here. Okay. So it's relatively easy to get to the drive assembly. I'm glad I didn't try and take the bottom off, since most of the houses are that way. Oh, hey, look, there's a broken something or another inside here. A casting. Let's get that out. I don't want that getting stuck in the gears. Probably casting from underneath. Anyhow, the motor wires are really tight, so that's why I can't flip it all the way over. The speaker wires have some slack, and of course the green light wire has some slack. There's 3 screws right here in the bottom, and then this drive mechanism, it looks like there's also 3 screws to hold in this pulley and gear system. So I'm going to remove those 3 screws first, so we can test out or check out this drive. And it looks like they're using a standard hobby pancake motor. Probably a 3 to 9 volt motor. A lot of the hobby motors are 1 to 9 volts, but I've noticed that they use the 3 volt ones more often. Probably because of the torque or power range is better. But once I get this drive assembly out, I'll get a better idea. Also, it is covered in a lot of grease. So if your piece quits spinning, and it's not something like you use the wrong power supply, or it's wedged, you got something wedged in one of these discs up here, it's probably going to be right here under 6 screws. So there's your drive belt. Easy to replace. Just pull out the top screws here, the second set of 3 screws there, and then those 3 screws to get to the drive mechanism. These 3 screws here allow you to get to the gears inside. The gear that you're probably going to break, because they always do, is this guy right here. It's a small little gear. Let me see if I can zoom in a little and make life easier. Push this over. So this one right here. It's the one that converts the large pulley into the gear drive for your mechanism. This gear right here is becoming more common, I've noticed, on Lemax houses. This year, 2020, the Toy Factory has this style gear, where it has the big teeth with the little teeth as the transfer gear. Maybe if one of them has a part number, it'll be easy to cross-reference and buy replacements. Not that they should break. Most of the power transfer that causes fracturing is the small gear here, and then the belt, of course. Especially if you store them somewhere where it gets warm. The belt will vulcanize into the shape it's in when it was turned off, and then when you turn it on, it just slips over or splits off. So, good. Let's continue dismantling and see what else we can find in here. Let's take out these 3 screws down here in the center and see if this center hub comes out. Now, I personally was reluctant to buy the Tilt and Hurl when I saw it, because every Michaels I saw it in, the pumpkin heads were the little cars were broken. Probably people knocking them off, or they just flew off and hit the ground. And yes, it's very similar to the carousels. So, they're modular plates, which is kind of nice. You got the hex head that fits in here. when this rotates, it turns the disc. If you can see right here, I'm going to zoom in again. You can see the teeth that transfers this drive gear. You can see as it's moving and causes this outer ring to move. And these bars right up and down the track here and here, this track is held on with this disc, which is why it's so greasy or oily. This disc presses on the inside and it fits underneath the back side. This slides back and forth to account for the up and down motion, which is pretty similar to how most of the carousels work. The ones where the horses go up and down, not all of them do. This would be the top. Invert this, and they use a very similar wave pattern and gear structure. It's just upside down from this. So technically, if you could find replacement parts, you could replace these panels. Problem is there's no replacement parts unless you find one that's broke. So let's tear it all apart. Oops, get a better look inside. I do this so you don't have to. So I'm just going to center this stuff so it's out of the way, make it easier to see. So when that drive motor goes down, it drives that one single gear, which then drives over here onto these teeth, which again are greasy. These teeth rotate the center hub. This stationary gear on the bottom, which is molded at the base, drive these planetary gears, which cause these shafts with the plastic bushing right here to spin and rotate your flat discs, which make the guys and girls spin on their little pumpkins. So, as you can see, that's what it looks like. So it's a very simplistic design. Technically, if you don't do anything to it, like fill it with dirt, put your hand on it, try and stop it, this should last you a long time, except for its weak points. Its weak points being the belt, which is common on all of them, and that little gear. So since we have some out there that aren't functioning, one of them that was suggested to me, or I've talked with the person via the internet, they said their motor isn't turning and it's getting hot. If your motor isn't turning and getting hot, most likely your motor's bad. It's an unfortunate thing. It does happen. Motors fail. So, to take your motor out, you take out these two little screws. Try not to lose them because they're really hard to replace. I'm going to take the belt off before I damage that. Alright, we'll just leave that screw in and not lose it. I'll pull it out actually. So, now that I got the drive mechanism out, you can see it just transfers, which is a pretty common Lemax house. That's why I took the screw out. So, very common Lemax house drive system. Belt transfers it into the gears. The gear reduction changes the torque and speed. And as you see as I rotate it, the bigger gear, there we go, let's get it in frame. I guess that helps. The bigger gear spins at a much slower speed, but it amplifies the torque to move all this moving mass. So, and then the gear here transfers it back into speed, and then the gears down here, of course, spin the little disc. So, it's all about the ratios. Alright, so here's a little motor, and the motor has some markings on it. Let's see what it says. You need a magnifying glass. Get out the old school 1970s magnifying glass. This motor is an 11440R11718 motor. That's this model number. You can also look it up as from the manufacturer as SGS ICL/SRT300CA is also the manufacturer's part number. I believe this motor is probably running at between 3 and 4.5 volts. There's no other markings on it. It's a hobby pancake motor like this. This is a hobby pancake motor I have lying around. I have several of them. This one, the part number is much easier to read. It's a sticker that's, black, and it's not engraved into the casing, where it's much tougher. So, I want to check the power of this to see what power is going to it. To get to it, though, I have to get to the circuit board. Because just like this one, just so you can see, the wires go through the casing. They're not soldered onto an external board or piece where you can test it directly. Or like this one, where you can test the power because the lugs are exposed. A lot of these hobby pancake motors, the wires come out of the casing. And I just acquired a whole bunch of them in the last couple of days. So this one is got a taller shaft. So we can try and cross-reference. This motor is rated to run continuously at just under 6 volts. And it's rated for a 5.9 continuous run. So, anyhow, let's see how we get to the bottom. I don't even see where the wires come from. Alright. Circuit board's in here. This piece that sticks out actually has where the wires run through the side. You can see there's a seam here, it's seamed here, and they have it glued here. So the circuitry is in here, and it just has a few wires that run. Probably it might be hard to see, but I'm going to turn it. There's a lifted section right here. You can probably hear the click. All the wires, this is my assumption based on the fact that I don't see anything else, run in this elevated part into here. So there should be about 6 wires. 2 for the motor, 2 for the speaker, 2 for the light that lights the center hub, the stack of pumpkins. So we need to get in here to check the voltage of the motor. If your motor burns out, you need to replace it, and you get another hobby motor. Personally, I wouldn't tear this piece off. So it's probably going to be a lot of work and possibly damage things. I would cut the wires really close to this motor as an example, because if it's bad, there's no point in keeping it. So snip the wires off right there. Get your new hobby motor. If it has a gear or has a smooth shaft, try and get one that has the same diameter shaft as that pulley. Pull the pulley off carefully so you're not to chip or break the pulley. Slide it onto your new one and take these wires, solder them, heat shrink them, or liquid electrical tape them together to what's already here. So that way you're not trying to tear apart the backing, because that would be a potential breakage point where if you slip, you could break the fence, break the walls, tear the lighting, which is a string of fairy lights as an example. So. Alright, let's see if the glue is brittle enough to just crack open or if I have to heat it. Because there's a big gap right there, and a small one right here. And there's a clip here and a clip here. So I'm wondering if I can just literally get enough leverage on it I can pry it off. Or I might have to take the base off. The base has push pin releases. If you saw the Toy Factory, it's the same. Right here, right here. It looks like these three. You stick something in and it releases the plastic pin. I think these three are for the wall. But these other two are trying to hold the hub together so it doesn't fly out and possibly break the wires. These two are for these clips right here. So, yeah, you can see I don't know if you can see it wiggle. So I'm probably going to have to break this glue. I'm going to use a small screwdriver blade and see if I can chip some of this away. Yeah, it's starting to come off. Trying to do it carefully so I don't damage or gouge the paint or stab myself. Some glue over here. There we go. Nothing on that side. This appears to be another tab. That's actually that's why there's glue on it. It's so it's held down. This is a click tab. That's what it appears to be. I would normally try and use a spudger, but I don't think it's going to be strong enough. There we go. There's the circuit board. So, spudger and a screwdriver to remove the pin. And I might have to actually pull the whole bottom off. You can also see the line right here. It has your wires. There they are. So that hump in the front is your wires. Don't need that right now. That is held on with two clips. Right there. So. these, I don't know which way they're supposed to move to release the pan. I think they go this way. One other thing, because it's common on stereos, is they put screws underneath these pads. Okay. There is a screw under this pad. It's under the pumpkins. The screw is right there. You have to break these guys off. So that's why these pumpkins are lined up the way they are. They're right over these pads and there's screws underneath them. Here's the edge of another screw hole. There's the edge of another screw hole. That's great. That's great. Which means there's probably one under the stairs, and that's why the stairs are a separate piece as well. So yeah. So this is why I would suggest unhooking the motor here, cutting the wires and soldering it, because getting to this circuit board is going to be a pain in the backside. Which you can hopefully see the circuit board. There's two. There's a green one and a yellowish tan. This is probably the main board with the blob chip, and this is probably a driver board based on all the resistors. This probably takes the light signal and has the resistor bank to dim the lights to the appropriate power level so you don't burn out the LEDs, because none of these LEDs can run on a 4.5 volt power supply. You would melt, or you'd burn the lights out. They don't melt because they're not incandescent. So let's see. Yeah, these pumpkins are on pretty good. I'd have to probably fire up the heat gun. Ooh, yeah. There we go. So these popped off. You can see the 3 pads of glue, and there's your screw hole. The other issue is they got glue in the screw head. So that's going to make it even more fun. So not only did I have to break the pumpkin out, I now have to get a screwdriver to puncture through the screw head to where I can get through that glue. Come on. This is not hot glue, melt glue. This is actually like super glue or acetate glue. The amount of heat it would take to cause this glue to make it easier to get to the screw would destroy this plastic base. So I am taking a small blade screwdriver and digging into the cross hatching for the Phillips, or the cross tip screw, and trying to get the glue out where I can get a bite on it and unscrew it. Not yet. I'm hoping that once I get a bite on it, it'll break the glue that goes around the edges of the screw. I basically made this so it's going to be really hard to repair if you have to take one apart. Yours might vary. Just could have been the one I have. The person got overzealous and the glue dripped inside. I don't know. Alright, well, she is definitely not coming out. I'd hate to do it, but I'm going to see about just trying to break the screw through the plastic. This is where you can severely damage your house. Or, in this case, it's a tilt and hurl. So because it's screwed in the plastic, what I'm trying to do is cause the teeth of the screw to strip the hole out and not crack the plastic on the top or the bottom. Like that. So it means that this screw, if I can pry this open enough and you can see, like so. I broke the tab off, so the standoff where it screws in is no longer attached. It's now attached to the screw right there on the top. So I break my house so you don't have to. Let's see if this one's the same way, because if I can get these two out, I might be able to fold this back enough to test power and let you know what the voltage is for this hobby motor. So now we're going to see about trying to break these pumpkins off carefully. They're really stuck. There we go. The only advantage to acetate glue is that if you can get it to start to split, it'll usually break clean. Usually. And yeah, they glued this one in too. Bastards. The glue ran down inside and filled it. And I'm going to see the same thing. I'm going to try and save the screw. I'm going to try and chisel out the glue. Oh, yeah, I can't believe they did this. I can, because again, these aren't supposed to be repaired, so they don't care. Right. So, I'm going to do the same thing. I'm going to try and crack the plastic inside, or strip the screw out, without breaking the top or the bottom. What I'm doing is I'm sticking it in up against the screw where the standoff is, and I'm twisting the screwdriver, which is causing force, separation force, and something's going to give. Hopefully it's the plastic piece that gives on the inside and not the where the grass is or the base itself. The weakest part, there we go. Good. Ooh, that's right up against the, there's a light wire here. There's a red wire right next to this screw as well. So I'm going to plug it back in before we're done and make sure I didn't damage that wire. So, here is the circuit board. Right there, it is the driver board. The motor. I'm going to try and probe in there. It's going to be really hard for you all to see it because it's literally only a ½ big gap. And the meter is going to take up most of it. So, let's find a spot where you can see the meter too. There we go. Plug it in, plug it in. Chink. Looks like all the lights work. Just going to turn off some lights to double check these. Nope, I lost my spotlights. And my pumpkins. So that wire that was right here, apparently I did break it. That's spinning beautifully. So I'm going to have to take the whole base off now to fix it. Lots of fun. So, since I damaged it, there's no going back. I know that if I take these off, I'm probably never going to get the screws out. They're probably full of glue. So I'm literally going to break every screw point all the way around. And I'm just going to have to glue the base back on. Probably going to have to use, I'll probably just use hot melt glue. Because that way it can be taken back off in the future. If I use acetate glue, it won't come back apart. I can't see if there's anything in here that I'm going to crush like a wire. Doesn't look like it. So, and there's a chance because this wire goes down inside. But there we go. Pop that one out. Right next to the wire. Woo, that was close. You'll be able to see it in a moment once I'm done, because I will show you the bottom. Glue is our friend. Alrighty. So, got all these fine little wires. This red and gray wire right here is what I caught with the screwdriver. The crush point is right here. So most likely when the screwdriver came to pop it, I probably split the wires inside the sheathing, which is why I lost my spotlights and the pumpkin lights. So, live and learn. How it goes. And now that it's all come apart, I'm going to have to put all these gears back in. But there's your circuit board. There you go. That one over there on the left with the yellow that has blank spaces under the lip. That is the light driver board. All the different resistors right here are the different resistance required for the lights. If you were to send 4.5 volts to any one of these LED lights, they will burn out. They'll just get dim and that's it. And then you're done. I have seen some people out there saying that a light is a light is a light. That is not true. Lights require a certain voltage and a certain amperage. If you deviate too far from that voltage or amperage, the light will either not turn on or it will never turn on again because you burned it out. LEDs are very sensitive to power. So that is why they have resistor banks like that one. And that's why these plugs are labeled like these. So the correct power goes to the correct string of lights. So I digress. That's just me telling you about power so you don't ruin your house. It's an expensive hobby. So plug the power back in like so. Motor spinning. You know the motor spinning. I'm going to see if these are labeled. The blob chip is right here next to the capacitor. I said I wish I could show it to you a little bit better. Maybe I can. This board's only held in by plastic stakes. I might be able to slide it out. Don't want to use anything conductive, so ceramic tweezers, which means if I touch any of the pins, it won't short out. There we go. Here's the circuit board. Woo! Look at that. It's out. It's out a little bit. So there's your blob chip. That's the control. There's your smoothing capacitor, most likely. All the circuit boards have a larger capacitor. Helps clean up the signal. I will assume that this is the motor, because it's red and black. It's only red and black wire in here. The other one's red and gray, and green and black. So, voltmeter, just to show you that we have good power coming in. I have 4.65, we'll just round up, volts coming in from the AC power supply. Sorry. And we are sending 4.6 volts to the motor. So this motor is running at 4.5 volts. It's running at full power. This is this gray and red wire is the speaker, which right now has nothing because I have the volume turned off. This red and black wire in the middle is the power coming in off the plug, the power of the circuit board. I'm sorry, this gray and red wire is not the speaker. This is what powers the lighting board. The speaker wire is underneath the edge. I'm sorry about that. Give you the wrong info. This big prong plug is from the switch. It's the on-off signal, and then the different white wires that are in here. You got white and another white with a little stripe and a light gray is your volume. It's called a potentiometer, and that's what changes the volume of your speaker. So we know that the motor is running at 4.5 volts. We're just going to round off to standard figures. I'll show you what the lights are actually pulling. If I can get the probe into one of these. Alright, so we're still getting 4.5 volts. Let me reference it to ground, make life easy. So this light string is getting 2.2 volts. Don't worry about the negative, it's just because I have the positive probe on the return. And this light string is getting nothing. That's probably the one I broke. That one's getting 1.75 volts. This is why it is important to know the power. There's the 2.2, and there's nothing on this one currently. That is why it's very important to know the power so you don't ruin stuff. So this hobby motor is a 4.5 volt continuous drive hobby motor. Like I said, they're pretty standard motors. Just cross-reference the number and you can find one. I would not recommend taking it apart this far to replace it. I would just cut the wires, solder on new wires, or splice them where you put the wires together and twist them and cover them with a heat shrink or tape or liquid electrical tape. Heck, you can even use hot glue. Some of the older houses, they sealed their junctions using hot glue. Now they actually use heat shrink. So They've gotten better. But what I need to figure out is how to make my lights work again that I damaged. So I can get my light string, my pumpkins, and my 2 spots. And you can see all the screws. That's what holds it on. Hopefully you never have to dismantle it this far. The only reason you ever have to dismantle it this far is to replace a light string. These are just fairy lights. You can buy them on Amazon and stuff, or dollar store sometimes, that are wrapped, fed through, and then wired in instead of using a battery pack. If your volume switch fails, because it unplugs right here, you can unplug it and replace it with another volume switch if you find one that's complete and actually works. If your power port fails, you'd have to remove it for that. So hopefully you never have to dismantle this. As you see, it's going to take me a little bit of time to reassemble it. Plus, not knowing they ran the wire right against the edge where I had to pry the screws out, I smashed the wires there and possibly right there. I think that's the one I broke. Yeah, that's the broken one. I gotta check that joint too. Fix those. Hopefully that'll make my lights light up again. Because if not, I got the green lights around the outside perimeter and the one white light on the center hub. So I am going to repair this, and then we're going to try and reassemble it so it looks good again. And hopefully it functions like it used to with no failures. As if not, I just damaged a very expensive piece. So, but again, better me than you, so you can figure out how to do it and fix it yourself at home and not be upset that you bought a house that only worked for a couple of days or a month and then quit functioning. I am going to research this motor and see if I can find a direct replacement instead of a generic replacement. So that way we ensure that it's its correct continuous voltage. Like I said, it should just be a standard 3 to 9 volt hobby motor. But I am going to cross-reference it. If I find a cross-reference, I will mention it in here. But I'm going to stop the video so I can fix my lights, do some cross-referencing, and then start the reassembly process. But what I am going to do is when I put the bottom back on, I am just going to run a bead of hot glue around this inner lip right here and sandwich it together. If anything oozes out when it dries, I'll take a razor knife, X-Acto knife, trim off the extra or crack it off with my thumb if it's not going to separate the plastic. And then I'll re-adhere the pumpkins I took off with acetate glue, Gorilla Glue, super glue, just like they had it originally, since I'll never have to take these off to get to the screws. If I hot glue it, I can just hit it with a heat gun and slowly work my way around and then separate it. So then we'll put it all back together, put the drive belt on, try and get all these planetary gears back into their place since they all started falling out. And that's it. We should be good. So we'll be back momentarily. Alright, I got it back together. And now I'm having the problem where the pumpkins don't stay on. So I definitely shifted something on it, because I was not having this issue before. But I fixed the lights as well. So you can see, turn off some of the lights. You can see that the rope lights are on, and then the white lights right here are working. I fixed the wire I cut a wire on each side when I was prying it apart. But I'm going to let you know that if you do have this and you have to take it apart, everything comes off of the center hub and goes down. The motor, if you ever lose the motor and it burns out and you need to replace it, the motor is an RF 300C. It's Robert Frank 300 Charlie. It's a standard hobby motor that comes in varying voltages, 3, 5, 6, and 9. You want to make sure you get a 5 volt motor. If you go onto Amazon, Amazon sells 5-pack motors that are very similar. They're a 3 to 12 volt motor, and the part number, if I can find it, yeah, can't find a part number for it, but it is a UDAX mini generator motor, 3 to 12 volt, and it's EUDAX. That motor has the exact same measurements as the factory motor that's in here, and it's a varying voltage, which means you don't have to worry about trying to get a 5 volt motor. So, oh, apparently my pumpkins are smacking each other. That's part of the problem. So, worst case is if I can't get them to stay on, I'll take the center off and readjust the timing on the plates. It's kind of a pain in the butt. But that is how you disassemble your tilt and hurl and reassemble it with some difficulty. The hardest part is getting all the plates to pop back in alignment. Once the plates are in, you just screw the center hub back down and you're good to go. If you need to replace the gear, belt, or motor, everything pretty much is done from the top. Since you saw me pry the screws out, I ended up just using hot glue to put it all back in. Yep. Keep losing this guy. So the hot glue, I just ran a couple of drops of hot glue where the screw standoffs were, and then squeezed it back together. And then I re-glued on the pumpkins. I pried off those and those. So it's back to the way it looked. So if you ever have to open it, it's all in here. You should hopefully never have to unscrew the base to get into where the circuitry is, where the power plugs in or where the volume knob plugs in, volume/on-off switch. The volume still works. So everything else should be through the center for your belt, your gears, and your motor if and when it fails. And I would highly recommend splicing the wires inside the center hub. If you saw it as a pain to get this base off, most likely everybody's, because they glued the stairs and the pumpkins on top. The glue is going to fill the screw heads and make it virtually impossible to remove them. So it's back together. It used to be a fully functional unit. Now I have an issue with one of my pumpkins not staying on. So it could just be the timing, where I might have to open it back up and then rotate that disc onto the little drive mechanism, which is right here in the center, and it's going up and down on. So other than that, till the next one.